Hi guys, I'm Abhishek. In this video, I'm going to show you about stack data structure. So let's start. In this video, I'm going to cover these points. First, we will understand about stack data structure. Second point is ADT of stack data structure. ADT means what operation we perform in stack data structure. Third point is related to analysis of stack operation. A stack operation like push and pop, some other operation as well. Like what is meaning of analysis? Analysis means just finding time complexity and space complexity for particular operation. Fourth point is feature of stack data structure, right? Fifth point is use of a stack data structure means where we have used a stack data structure. And last 2 point is related to its implementation. So in implementation part, I will show you about how to implement a stack using array and how to implement a stack using linked list. So first let's start with what is a stack data structure, right? So a stack is a linear data structure that follow last in first out or first in last out MAC principle, right? A stack operation, most common operation in a stack is push and pop, right? A stack operation like push and pop of element take place at only one end of a stack, that is called top of a stack. The element which is present at top of a stack is called top element, right? You can implement a stack in any programming language like C, C++, Java, and Python as well, right? So first we understand what is meaning of last in first out or first in last out principle, right? So take one real-time example, right? Every day you will see in your homemade make bread and chapati and put into hot pot or any container. Your maid each time put one bread into hot pot, right? Same when we go for lunch and dinner, then you open the hot pot or any container, right? And take one bread from it, right? When you go for, in simple word, you can say putting a new bread into hot pot is an example of push operation in a stack. A remove bread from hot pot is an example of pop operation from a stack. Suppose if you want the bread or chapati at bottom, first we have to remove all the bread from top. This type of arrangement is called first in last out or last in first out mechanism. So every time when put a new element that is put at top of the stack, and when you remove any element from a stack, then we remove element from top of the stack. This is a representation of a stack, right? So now understand about a stack operation, right? So most basic operation of a stack is push and pop, right? Push means just putting element into top element into a stack, and pop means just remove item that is present on top. Apart from this operation, some other operation also need to perform in a stack, like check a stack is full or not, same like a check a stack is empty or not, search any element into a stack, and check size of a stack at any point of time, right? So let's start with push operation, right? Same, push means add item or element into top of the stack, right? So let's see the what is algorithm of push operation. So algorithm of push operation contain simple three step. First step is check a stack is a full or not. Suppose this is a stack, right? And top is pointing here, pointing element 10, right? So check first a stack is a full or not, right? Second step, if a stack is not full, then print a stack. Suppose a stack is a full, right? Then print error and exception like a stack overflow. It's totally depend upon you and your requirements, and program will be terminated. Suppose you show if a stack is full, then print this message. If a stack is not full, then print this message. It's upon you, right? Third step is if a stack is not full, then increment the top and add element, right? So suppose in this example, suppose this is a stack and that contain 4, 5, 9 and 10, top and pointing here. Suppose we want to insert element 12. So first we increase the value up. So value of top. So we increase value of top. So top is pointing here, and then we insert data into this position. After inserting the data into a stack, the stack look like this, right? Analysis of push operation. Analysis means just finding the time complexity and space complexity of the push operation. So push operation time complexity is order of 1, but how? The time complexity of push operation or push function is order of 1 because we always have insert and add element on top of a stack, which is one step process. We can see in this stack, right now your top is here. If you want to put element 12, just we increase the top value by 1, right? So this is pointing here, and we insert the data 12 in this position. In this operation, no any loop is required. Just we have increase one variable value. So don't take any loop. So this complexity is constant, and this is represented order of 1, right? This is all about push operation. Push means nothing but just add element into top of the stack, right? Right. Now see about pop operation. Pop means just remove an item from top of the stack, right? This is a stack, and this contain 4, 5, 9, 10, 12, and top is pointing here. So first we see the algorithm of pop operation, right? So in algorithm of pop operation also contain simple 3 step. First we check stack is empty or not. If a stack is empty, then print error or exception like a stack underflow, and program will terminated. Its error message is totally depend upon you and your requirements. If a stack is not empty, then remove the element that present on top of a stack and decrease the top, right? So let's see one example. This is a stack, and the stack contain 4, 5, 9, 10 and 12. Now top is pointing here. If you want to perform pop operation, so first we remove element that is present on top, right? So we remove the element 12, and then after we decrease the value of top by 1 row, right? So we decrease the value. So after done pop operation, the stack look like this, and this stack contain 4, 5, 9 and 12 because top element is removed by pop operation, right? Right, right. Here we see the analysis of pop operation. Analysis means same, just finding the space and time complexity of particular operation. So same like push operation, pop operation also take constant time. How? So the time complexity of operation is order of 1 because we always have to remove element and top of a stack, which is one step process, right? In this example, you see you remove element 12. In this operation, we just decrease the value of top. So no any loop required. So its time complexity is order of 1, and you can say constant time complexity, right? Peak operation, right? So peak operation get element that is present on top of a stack without removing it, right? So major difference between pop and peak is pop basically remove the item from top of the stack, but peak is don't remove element that is present on top of a stack. Peak just returning the value that present on top of a stack without removing the element. So first see the algorithm of peak operation. So same like as pop operation, the uh, algorithm contain 3 steps. So first we check the stack is empty or not. In this case, a stack is not empty. So next we check the if a stack is empty, then print. Suppose this stack is empty, then print error or exception message like underflow, and program will be terminated. The exception and error message show based upon your requirement, and it's totally depend upon your requirement and you. If a stack is a not empty, then return element that present on top of a stack without removing the element. Right. So let's see this example. This is a stack and this is contain 4, 5, 9, 10 and 12. After peak, we get the value present at top. So top is pointing here, so we get the value 12, but this value is not removed now. But in case of pop operation, this value is removed and top is decreased by 1. So pointing here, but in case of peak operation, just return the element present at top of the stack, right? So here see the analysis of peak operation. Peak operation also take time complexity is order of 1, as like as push and pop operation. The time complexity of peak operation is order of 1 because we always return element that present on top of a stack, and which is one step process. So time complexity is push, pop, and peak is constant, and that is order of 1, right? So right now we cover the stack, stack operation like push, pop, and peak, right? And all push, pop, and peak all have constant time complexity, right? That is order of 1. Next one is full. Suppose you want to check a stack is a full or not. In this case, we use is full function, right? How to check a stack is a full or not? If value of top value of top and size of a stack minus 1 is equal, then a stack is full. It is a Boolean return type, means it's return either true or false. If a stack is a full, then it return true, and if a stack is a not full, then it return false, right? First, we see the algorithm of each full operation. So in each full operation, algorithm contain 2 steps. First step is check stack is a full or not, right? So this is a stack representation, and that contain 4, 5, 9, 10, and 12, and top is pointing here, right? So we check okay, this stack is full or not. So just we check the top value, right? Top value, and check the size of this array. Suppose we implement using array, so check the size of array and just minus 1 because array index is start with 0, and check the top value and size of a stack minus 1 is equal or not. If both are equal, then a stack is a full, otherwise not. So it is also contain also take constant time complexity, because here we don't perform any looping operation, just we check the uh, one or one arithmetic operation, right? So time complexity of each full operation is also order of one, and that is constant, right? Right. This is a search operation, right? This is also very important, right? When you use search, basically, if you want to know about any particular element present in a stack or not, sometime we want to know this element is present in a stack or not. In that case, you should go for search function or search operation. It's take element as a argument. Suppose you want any finds any element to, right? Then this function take element as a argument and return either position of an element in a stack or true. It's totally depend upon your requirement or your implementation that we want, right? First, see algorithm of search operation. This is a stack and this is contain 4, 5, 9, 10 and 12, right? So algorithm of search operation contain simple 3 step. First step is same, right? Check a stack is a empty or not. In second step, if a stack is empty, and then it return not present in a stack, the element not present in a stack, and whatever you want, right? Third step, if a stack is a not empty, then search the element into a stack. And the analysis upon the search operation. This is a very important, right? So in search operation, time complexity is order of one. In order of one in best case, right? When when search element present and top of the stack, and order of n when a stack when element not present on top of a stack. See, suppose you want to search element 12, right? So we check the element present and top equal to element you want to search. In this case, the top element and this element is a right equal. So in this case, no any looping operation we need to perform, right? Just we check one arithmetic operation. So it takes constant time. But suppose, so in best case, it take order of one, and best case when, right, when search element present and top of the stack. Suppose you want to search element 5, right? In this case, the element present and top is not equal to element that you want to search, right? So in this case, we take one loop and we need to search the element in whole stack. So in this case, we search element from 0 to nth position. So in this case, worst case, it take order of n time complexity. So it's all about search operation and what algorithm of search operation and analysis of search operation in best case and worst case, right? This one is about a stack data structure, right? So a stack contain element of similar data type, means a stack contain, we create a stack that contain integer, right? A string. So we can't create any stack that contain integer and right. A stack contain element of similar data type. Similar means same type of data, right? Second one is a stack follow first in last out on last in first out principle. Each push and pop operation increase and decrease the size of a stack by 1. That means size of a stack change with each push and pop operation. Push operation is used to insert new element into a stack, and pop operation is used to remove element from a stack. Push means insertion and pop means deletion that allow at only one end of a stack, and that is called top of the element, right? A stack is said to be overflow when a stack is completely full, and it is said to be underflow if it is completely empty. So this is all about a stack data structure, right? Right, this is a very important point, use of stack data structure. So first, First example is to reverse a word. Suppose you want to reverse any word, then we go for a stack data structure. How? Push each letter of given word to a stack one by one, and then pop the letter from a stack. Because of LIFO principle of a stack, we will get letter in reverse order, right? So first we push one L, push all the letter upward one by one, and then we have pop the element from a stack one by one. Then we have get the letter in reverse order. Second one is expression conversion, right? Expression like infix, prefix, and postfix. We can use a stack to convert one form of expression to another form like infix to postfix and same like as other combination. Like backtracking. Backtracking means if you want to access access the most recent data or element in series of element, this is a backtracking recursion. To execute any recursive program, a stack data structure is a required. So execution of recursive program stack is a required, right? Syntax parsing. Most of the compiler use a stack for parsing the syntax of expression program block before translating into low-level code. So this is all about use of a stack, right? So till now we covered what is a stack, what is operation of a stack, right? And we see all the operation one by one and its algorithm, right? And then we see the all about the stack and use of stack data structure, right? Thanks for watching this video. If this video is useful for you, then don't forget to like this video and subscribe this channel. Thank you.